When you think about a keyhole surgery, what comes to mind? Probably the surgeon's incredibly steady hands, right? But what if I told you the success of that entire operation has less to do with their hands and more to do with some hidden geometry? Yeah, that's what we're going to unpack today. We're talking about how a complex procedure becomes a work of art, and it all hinges on where you make that very first cut. Wow. Think about that for a second. Every laparoscopic surgery succeeds or struggles not because of your hand, but because of your ports. That's a huge statement. It's telling us that the most critical decision a surgeon makes happens before they even really start the main part of the operation. The whole thing, success or failure, it all comes down to these little entry points, what they call ports. So, what's the real difference here? Between getting it right and getting it wrong? Well, it's pretty much everything. It's the difference between a battle and a dance. And this slide just lays it out perfectly. On one side, you've got a total battle. Imagine instruments bumping into each other, the surgeon fighting against awkward angles, getting tired. It's a constant struggle. But on the other side, you've got a dance. The instruments move fluidly. The actions are precise. The surgeon is comfortable. It's just a success. That's the power of good port placement. And it's kind of crazy to think that this whole field is still pretty new. It all kicked off back in 1987 with the very first laparoscopic gallbladder removal in France. And surgeons all over the world saw this and went, wow, this is a game changer. But they also realized something really fast. To make this amazing technique work for everyone everywhere, they had to crack the code. They had to solve the geometry puzzle first. So, how did they solve it? Well, the answer came from a place you might not expect. They found inspiration in a shape that's, pretty familiar to a lot of us. To create a kind of strategic map on the abdomen, they turned to the baseball diamond. Okay, so every baseball diamond needs a pitcher's mound, right? That's the center of the action. In this surgery, the pitcher's mound is a tiny little anatomical spot called Callet's triangle. It's the target. Absolutely everything else in the operation is positioned and planned around this one single super critical spot. All right, let's build this diamond right on the patient. First up, you've got the camera, which goes in at the belly button. That's your home plate, giving you that perfect view of the whole field. Then, the surgeon's instruments. The left-hand port is first base. The right-hand port is third base. And finally, you have a retraction port that acts like an outfielder, just holding the gallbladder up and out of the way. Simple, right? But absolutely brilliant. And the result of all this isn't just some random shape on the abdomen. No, it's a functional masterpiece. This diamond setup is specifically designed for three things: to give the instruments total freedom of movement, to give the surgeon's eyes a sense of depth, even though they're looking at a flat screen, and maybe most importantly, to give their brain the confidence it needs to do the job safely. Okay, so let's get into the nitty-gritty. Let's talk about the exact numbers behind this diamond, because these aren't just random suggestions. These are the geometric rules of the road that are all about keeping the patient safe. First, let's talk distance. The camera has to be about 15 to 20 centimeters away from the target. So why that specific number? Well, think about taking a picture with your phone. If you get way too close, all you see is a blur. You lose the big picture. But if you're too far away, you can't see any of the important details. That 15 to 20 centimeter range, that's the geometric sweet spot. It's perfect vision. Next up, the angle. The two main instruments that the surgeon is using, they need to come together at the target to form a 60-degree angle. The best way to picture this is, imagine trying to pick up a single grape with two chopsticks. That 60-degree angle is what gives you the most control and precision. It's also what stops the surgeon's hands from bumping into each other and keeps their wrists from getting totally exhausted during a long surgery. And then there's the spacing on the outside of the body. The ports on the skin have to be at least 8 to 10 centimeters apart. Now, this is a rule they learned the hard way. In the early days, surgeons would put them too close together, and it led to this thing they called sword fighting, where the handles of the instruments were just constantly clashing outside the patient. You can imagine it made doing anything precise inside the body basically impossible. And believe it or not, the geometry even includes the surgeon's own body. So they raise the operating table up high when they're putting the ports in, because that gives them more control. But then for the really delicate work, they lower the table down so their elbows are at a nice, comfortable 45-degree angle. And the key takeaway here is so simple, but it's absolutely vital. A comfortable surgeon is a safe surgeon. It's as simple as that. Now, this whole elegant system, it didn't just appear out of thin air one day. It wasn't designed in some pristine lab. Nope. This was forged in the heat of the operating room, over years and years of struggle, a lot of frustration, and some pretty brilliant improvisation. And that journey to get here was, well, it was messy. After that first surgery back in '87, the late '80s were basically the Wild West. I mean, surgeons were trying everything, all sorts of different port setups. It wasn't until the early '90s that this baseball diamond idea really took hold and became the global standard that's still used all over the world today. And this quote, this just says it all, doesn't it? We fought more with our instruments than with the gallbladder. Can you even imagine? Surgeons were literally fighting their own tools more than they were fighting the actual problem. That kind of struggle, it just wasn't sustainable. It's exactly what drove them to find a better, smarter, more ergonomic way to do things. And what's so amazing is just how universal these geometric rules are. You had pioneers like Dr. Tehemtin Udvadia in India who took the concept, adapted it for different patients, and proved that the principles worked everywhere. If you got the geometry right, you could get world-class results no matter where you were or what resources you had. Okay, let's bring this all together. What does all this history and geometry actually mean for a surgeon who's standing in an OR right now about to start an operation? Well, when that surgeon picks up the instrument they used to make the first port, it's called a trocar, they're doing so much more than just making a hole. They're actually drawing a geometric map inside a living human being, a precise, invisible map that's based on decades of trial, error, and hard-won wisdom. Really, when you think about it, every single successful keyhole surgery that happens today is just recreating that same blueprint. It's a design that was perfected over decades, across countries, by pioneers who literally changed the face of surgery forever. So, after all of this, what's the one thing you should really take away from this? What should you remember? It all boils down to this. Those ports aren't just holes. They're the surgeon's compass. And if you place that compass wrong, you're lost. But if you place it right, it guides you safely to your destination, every single time.